to today's lesson. Today we are doing quick review number 2. For today's objective, we have to review interval notation and rounding. Our language objective is to explain how to write an inequality using interval notation. So let's take a look at our thinking for today. Today's thinking, we are going to be answering, how do we represent an inequality using interval notation? So there are different ways of representing numbers. Today we are working with interval notation. For interval of numbers, we use the following notations. So we are given an inequality, and what we are going to do is change that to some interval notation. So let's go through these one at a time. For the first one, we have A is less than or equal to X, which is less than or equal to B. If I am representing those values using interval notation, I would say X is an element of bracket A comma B, close bracket. Those brackets are telling me that A and B are included. For the second one, we have A is less than X, which is less than B. So I am going to start off the same way. X is an element of. This time A and B are not included, so we do a backwards bracket. Now this looks a little bit weird because we are not used to looking at our interval in this manner, but this is how IB uses this interval notation. What you are used to or have seen in the past, when we are dealing with numbers that are not included, we tend to put parentheses. But since we are in this IB class, we are going to be using the proper notation for IB. Okay, the third one, we have A is less than or equal to X, which is less than B. So I am starting off with X. It's an element of. A is included, so that means normal bracket, comma. B is not included, which means backwards bracket. Again, that looks a little bit weird. We tend to see this as bracket and a parenthesis at the end. The next one, we have A is less than X, which is less than or equal to B. So we have X is an element of. This time A is not included, so backwards bracket, comma. B is included, so normal bracket. And just because I'm writing the way that you're used to seeing it, I'll do it in green. Then we have been given X is greater than or equal to A. So X is an element of. A is going to be included all the way to positive infinity. And infinities are never included, which means backwards bracket. We would have written it as, and the last one here, X is less than or equal to A. So similar to the previous one, we have X is an element of. This time we're dealing with going to the negative infinity side. So negative infinity not included, all the way to A, which is going to be our biggest value, and that A is included. And the way you have seen it in the past, there we go. So we have to get used to the bracket notation that IB uses here. Let's look at example 1. It says we are going to be using set builder notation and interval notation. So for part A, we're going to write our answer using set builder notation. For part B, we want to write it using interval notation. Let's look at question number 1. So we have the set of all integers between -100 and 100. Using set builder notation, what we are going to do is start off by inputting our curly brace. We're going to say X such that we are going to input the inequality. So we have -100 less than X less than 100. Those are all the numbers between -100 and 100. We're going to add a comma, and we're going to specify the set that we are dealing with. In this case, they said the set of all integers. So I'm going to say x is an element of the set of integers, curly brace. For part B, we have to write this using interval notation. So we're going to start with backwards bracket, negative 100 because that's not included. And we're going to go all the way to 100 and that value is also not included. Question 2 starts off by saying the set of all real numbers that are greater than 1000. So we are going to start with part A, which would be curly brace, x such that. We're going to input our inequality, in this case, numbers that are greater than 1000. I'm going to input my comma. At this point, we're going to include the set that we are working with. So x is an element of the set of reals. For part B, we want to write this inequality using interval notation, which would be last question, the set of all rational numbers between 2 and 3, excluding 2 and 3. So for part A, for part B, backwards bracket for both because both the 2 and the 3 are not included. So our second thinking question is, how do we round to different decimal places, something that we should have done in the past. The numerical answer to a problem is not always exact and we have to use some rounding. There are two ways to round numbers. A, in a specific number of decimal places, DP for short, decimal places. We can also round up before the decimal place. So let's practice some of these rounding skills. Example 2, rounding numbers. We have A, consider the number 123.4567. So number 1 wants us to round to 1 dp, 1 decimal place value. 1 decimal place value is the tenths place. So that would be 123.5. For number 2, we want to round 2 decimal places, which would be to the nearest 100. And that would be 123.46. Number 3 wants us to round to 3 dp, which is the thousandth place. So we would have 123.457. Number 4 wants us to round to the nearest integer, which means the nearest whole. So in this case, that would be 123. 5 wants us to round to the nearest 10. So here we would be rounding 120. This would be considered the nearest 10. Rounding to the nearest 100. So that would be 100. Here's my nearest 100. So there's a mix of rounding that you might see or have seen in the past. Let's look at part B. Same kind of thing, just dealing with decimal values. So here we have considered the number. I'm just going to highlight it. And we are going to do the same kind of process. Let's see. 2 dp's. 2 dp's means nearest 100. So 0.04. 3 dp wants us to round to the nearest 1000. 4 dp would be 0.0436 and round to 6 dp. All right, so I will see you in our next quick lesson video.